Okay, so guys, new formulas. We're talking tangents today. Still going to be radian measures, possibly degree measures. So yeah, go back and refer to your list of radian measures written with the common denominator if you want to or need to. Okay. Notice these formulas are a little more involved, right? So for tangent, the sum and the difference here. If it's a difference, then we subtract the two, the tangent of the first angle minus tangent of the second. And then in the denominator, we've got 1 plus and the product of those two. So we multiply those together. So the signs are kind of important. Notice if it's plus on the inside of the parentheses, then on the right-hand side, it's plus on top, it's minus on the bottom. Notice in the top, we're either adding or subtracting. In the denominator, the two tangent values are getting multiplied together. Okay, so we're going to look at a couple of examples of this.
Who came up with this?
Who came up with what? Yep, there you go. All right, tangent of 7 pi over 12. We need two radian measures that either add or subtract to get 7 pi over 12. So what are we going to use? What do you want to use, guys? Say that again, Ryan. Okay. Shh, guys. Okay. So pi over 3 and pi over 4. Brayden, you need to either shape up or you're going to be shipping out. All right. Tangent of, so we're going to use pi over 3 plus pi over 4. That adds together to get the 7 pi over 12. If you're not sure about that, go back and look at that previous page where you have your radian measures with the equivalent fraction, so you can look and add those together. Okay, what that formula says, though, is that we are doing tangent of pi over 3 plus tangent of pi over 4 all over 1 minus tangent of pi over 3 times the tangent of pi over 4. Okay, and now we're going to unit circle. And you'll see these get a little bit more involved because of the fractions and we're dealing with radicals. So tangent of pi over 3. Tangent, remember, when we're looking for tangent values, it's the numerator of the y over the numerator of the x. So Chris, tangent of pi over 3, what do we get?
Tangent pi over 3.
Mm-hmm.
Radical.
Numerator of the y over the numerator of the x.
Radical 3 over 2 over 1.
Numerator of the y over the numerator of the x. So just root 3, there you go. Okay, plus tangent of pi over 4. Amira, what do we get for that? Numerator of the y over the numerator of the x at pi over 4. 1. Okay, and then in the denominator we get 1 minus, guys, whatever we got up on top, we're going to multiply those two things together down here in the bottom.
So it's just root 3.
So it's just 1 minus that root 3 because obviously we're multiplying by 1, right? Okay, so here's the issue. We have root 3 plus 1 all over 1 minus root 3. We've got radical in the denominator, and so we've got to rationalize. So think about the fact that we've got to multiply by the conjugate. So we're going to multiply by 1 plus the square root of 3 all over 1 plus the square root of 3. And then we're going to have to FOIL the top, right? So first gives us square root of 3. Outside gives us square root of 9, which simplifies to 3. Inside is 1, and then last is another square root of 3. So that's numerator. Denominator, we don't have to FOIL completely, we just have to multiply first and last, right? So if we multiply the first, we get 1, and then minus, for the last, we get the square root of 9, which is equal to 3. Okay, and yeah, now we got to kind of clean things up. We need to find common, what's in common that we can add together. So I'm going to kind of color code here for you. So we get 4 plus 2 root 3 all over negative 2. And we've got Mickey Mouse ears, don't we? Right? So, yeah, you got to be looking and watching for Mickey Mouse ears. You should get those pretty much every time. And so we want to divide out. If there's a negative in that denominator, you want to include that also. So this simplifies to just negative 2 minus. You can put the 1 if you want to, but you really don't need to. So just negative 2 minus root 3. Oop, let me make that a different color. So here's final answer. Guys, just as yesterday when you all picked up on the fact that we get the square root of 6 and the square root of 2 and it's all over 4. For all of these tangent ones, you're going to have a 2 and you're going to have a square root of 3. Okay? That's it. Now, they can get a little bit more involved, so I want to show you this next example because I got to show you something that can happen. Yes?
So let's say on the test we just blank on how to do this. We write one of those, we get it right. Do we get points?
You might get 1 point for the answer, but the work is what's worth all of the points, pretty much. Right? Okay. Tan of 75. If you notice, we'll talk about this in just a second. You'll see why in just a second. But yeah, so we're going to use, I need you, what happens here, guys, in some instances you can't really avoid using the 30-degree reference angle. So I do want and need you to see what happens and why you want to avoid it and how you're going to deal with it if you have to deal with a 30-degree reference angle. But then in general, we'll talk about, and for the most part, if you can, avoid the 30-degree reference angles, avoid the something pi over 6. But we're going to do this one for now. So we're going to use 30 plus 45, so that means we're going to have tangent of 30 plus tangent of 45 all over 1 minus tangent of 30 times the tangent of 45. Okay. All right. So here's the issue. The tangent of 30, we end up having to rationalize that. So we get the square root of 3 over 3 plus tangent of 45 is 1. And then all over 1 minus, if we multiply the square root of 3 times 1, we get, the square root of 3 over 3, then we just get that, the root 3 over 3. Okay? So the issue is that we've got fractions within fractions. We have a complex fraction. So we want to kind of we need to think common denominator and combine this together. All right? So we end up with the square root of 3 plus 3 all over 3, and then all over 3 minus the square root of 3 all over 3. If we do keep it, change it, flip it, think about what happens here, guys.
It'd be 3 over 3 minus.
So the 3's divide out, right? Okay, so what we have left is root 3 plus 3 all over 3 minus root 3. And now we've got to rationalize. So all of this work was just to get the fractions together and deal with the fact that we had this complex fraction here. Now we've got to actually go back and actually rationalize. So now we're going to multiply by the conjugate. So we've got to multiply by 3 plus the square root of 3, top and bottom. Okay, so when I FOIL on the top, I get 3 root 3 for first term. That's outside, inside, and last. And then in the denominator, I'm just doing first and last because outside and inside are going to add to 0. So 3 times 3 is 9 minus 3. Okay, so now we've got to do, hey there.
Hey, can I have some graph paper to do that?
What now?
Can I have some graph paper?
Yes, right under the basket there. Okay, so 9 plus 3 gives us 12 plus 6 root 3. There you go. All over 6. And now we can do our Mickey Mouse ears. And we get our final answer. So this is 2 plus the square root of 3. Okay. All right, so it's not terrible, but having to deal with that 30-degree reference angle was definitely more involved, was a lot more work than the original problem, right? So that's why, if you can, you want to try to avoid that 30-degree reference angle or the pi over 6s. In some instances, you just can't, and you're going to have to deal with the 30-degree reference angle. But in other instances, use different values so that you can avoid that. Okay? All right. I want to show you, there's a couple other examples here where we're kind of working backwards, that type of thing. So I want to go over those with you. Actually, I think there's just one, but I don't remember. Okay. You good? Where's your lid? You ready? Okay. Just hold on. Okay. This is another example like we saw yesterday with the sine and cosine problems where we're given what looks like the right-hand side. We want to rewrite it so that it looks like the left-hand side, and then we can simplify from there, right? So we know it's a tangent because of the tangent format there. We know we've got the 78 and the 18. Because it's minus here, we know it's got to be minus there. What, Davis?
I was going to say we had to minus.
Yep, we do have to minus. So when we subtract 78 minus 18, we get tangent of 60 degrees. And tangent of 60, when you go to your unit circle, is the square root of 3. Okay? All right. If you look, it seems a lot worse than it is. So classwork and homework, you need classwork, basically. You should be able to finish this. On the next couple of pages, the problems that were tangent ones, now you can do those. So you need to do those on 16 and 17. And then on page 24, you are doing all of those. Okay? So 16 and 17, and then page 24 you're jumping to. Okay?